Hi Shed Hackers, this is going back to this paper 21492E, and it's the sample assessment paper for Unit 1. Really important, it's Unit 1, okay, and it covers Level 1 and Level 2. Okay, so you Shed Hackers, we finished off with a little piece of work here on types of floor, and we looked at the DPC and so forth. So some detail there I need you to research. But we're moving on to question 7 here. And it says, give 2 functions of a foundation. Well, you know, there are many functions to a foundation, but the primary functions are is to transfer all of the design loads. Okay, loads that have been designed for the building safely to the ground or the earth. Okay. There must be no movement. There must be no movement of the building afterwards. Okay, and if there is, it's called subsidence. Okay, and part 2, to provide a stable base, of course, this is all part of it, to provide a stable base for the structural frame, and the frame could be metal or timber, couldn't it? E.g. Now I'm writing more here than you'd need to, just so you have a similar question, you can tackle it in a slightly different way and get full marks. So it could be concrete, steel frame, or even timber. Yeah, some are even timber. Some low rise are timber, high rise or medium high rise are concrete and steel. Okay, very high rise can be these two, of course. Right, moving on to question 8. The use of structural insulated panels, and the acronym for that shortened term is called a SIP or SIPs, is a modern method of construction. Okay, now it's when they actually pre-make them on site, and you have a whole section of a building made up ready. And I'll try and find a little part in a book if I can in a moment for you for that. And the idea of these modern pre-made wall panels, it's a wall panel really, is to allow speediness of construction, and also it can actually improve quality. So I'm going to put a lot of detail into this one to save time. At the construction site. So it saves time, so it's already made. So less fuel is used, and less, I suppose, wastage on site. Often things are damaged on site when they're left there. So if it's brought in on site and put up, you'll find it's a better solution generally. Now another reason, it tends to save money. So we'll put that here. There is only one transport cost. Okay, there is only one transport cost. and that means that you're not having to transport bricks, blocks, and all the various materials to form a wall. You can do it in one go, it's one delivery. Not several transport journeys, that means. That would need to be made on site. That would not several, that would be needed, sorry, be needed if made on site. Okay. Another one, I'll add this, it can be a lighter construction method, lighter in weight. It can be faster. And actually I'll do another one. The quality insurance. Quality can be managed more effectively. Okay, because it's pre-made off-site. So it's e.g. we'll put a note E.G. pre-made. And another word for pre-made is fabricated. Okay. Right, okay, moving on. So hopefully that's useful for you. And this is question 9. I'm looking at something I've done before to make sure we are. So the excavation of a substructure for a foundation has a number of hazards. Hazards is another word for, in effect, dangers, possible dangers. Okay. And it says complete the table to show the missing hazard and the missing associated risk for this type of excavation. So it's the associated connected risk. That's important, we know this. It's the risk associated connected, that's what it means, with the hazard. Okay. Oh, this is very easy. Collapse of the sides of the excavation or trench. Okay, there's an example. It says severe injury or fatality, that means death to workers. And it's got one here we've got to fill in. Flooding and potential drowning. So what do we do to minimise that or reduce that? The danger, the hazard is deep excavation. And you have groundwater. Okay, so you've got deep excavation and you have groundwater build-up because of the nature of the deep excavation, allowing water in the ground to find its way and into the excavation to fill it up. And it's got here hazard, gas may escape or may be in the hole, whatever it is, and the danger is explosion. And also working in a confined space. In a confined space. Okay, so it's associated with, dealing with gas, because you have to dig down to find out where it's leaking from, usually deep in under the ground, and you're working in a small space, a confined space. And, that can cause asphyxiation, they call it, where you can't breathe properly. So let's put that word down there. Asphyxiation. Spelling for it there. Okay. Explain, this is part B. Explain 2 control measures used to prevent the collapse to the sides of an excavation. Okay. Right. I'm going to draw a little picture. There's the ground. This is a sectional view looking inside. There's the ground on the other side. You've dug a hole quite deep. Let's say this is 3 meters deep. Quite deep. Okay, 9 feet roughly. And this is all the earth around the side. So it's looking through the side view here. Well, you can put timber, I've got here. And you put timber all the way down. Large pieces of wood all the way down the excavation and all the way across it. And every couple of meters you'll put timbers across and you'll brace it. And these could actually be pre-made steel supports, and you'll have one here and one perhaps 2 meters down. There's the adjustment that can be made. And these are supports or tie beams. Some people just call them braces. It's a brace, stroke, tie. This is all earth on top. So there's a lot of pressure actually trying to push those sides in. Okay. And there are many other methods. If it's a very large excavation, you can use steel sheets. Secant piling it's called. Okay, and you often see that on the seaside. You see metal secant piling sticking out, and it tends to, on the top view, tends to look a little bit like this. And you have another piece connected, going off. It has this sort of rolled metal flange, and it connects and goes off. So this is looking down, and you may have the sea this side and the sea wall that side, and it keeps all the earth from falling that way. Okay, sheet metal piling, secant piling. Look that up, secant piling. So these are piled into the ground, and these could be vertically, 10 to 20 meters deep. Right, so this is more for the domestic trench, is for perhaps a strip foundation, or even excavation for road surface repairs. So let's put that. It's to provide, explain, to provide a secure, oh, my paper's coming loose. Provide a secure and stable barrier to the sides, preventing any persons from falling in. Okay. And also, so you can actually provide support to stop people actually falling into the excavation. So this comes up quite high. And also, the other reason would be provide metal or timber shoring to stop ground or earth movement. Okay, to stop the trench collapsing. Explain 2 control measures used to prevent the collapse. Okay, and I suppose a third, remove any all water. If you get water that actually appears in the bottom here, often it loosens the soil. It becomes less compacted and the soil collapses in. So removing the groundwater here really important. Okay, and you can put a sump pump in, dig a hole and put a pump in it, pump the water out. Okay, so I hope that that has helped there. Yeah, pump water out, move any water. Oh, the other one, and I put this down, we'll put it down as a 4. I know they're only asking for 2 control measures. And it's going to be avoid any heavy loads. Okay, next to the excavation near. Sorry about this. Excavation sides. Really important. You've got a big lorry here. It's going to try and force some of this load and perhaps break off a lot of the earth and force it into the hole. And it does happen. Another way to prevent it, when you've dug the hole, try and fill it with what you need to fairly quickly. If it's going to be a concrete mass poured foundation, just fill it and then you remove the danger straight away. Okay, that's a way of avoiding trench collapse as well. Okay, moving on to 10. I hope you're enjoying this. We're getting through it. And it says a client has commissioned an architect as a designer to design a house in a location with high rainfall and high wind speeds. Explain 2 appropriate specifications for the external cavity wall. Okay. A specification is a feature of that design. Okay, feature. I think that's the best way of doing it. So you could write strength of wall to be increased. Strength of wall to be increased. Okay. You could even give an example, e.g. reinforce the wall with steel. Okay, or you could just use more wall ties, than normal, perhaps. Now let's just have a look at a cavity wall. Okay, we could cavity wall. Sorry about that. There's one there. Going down to our foundation. You could have a nice deep foundation rather than a shallow one, couldn't you? Here's your foundation. You could put reinforcement in the foundation as well. Backfill there. There's your ground level. Insulate inside. Lots of wall ties in the wall as you go up. This is your brickwork. This is your block. This is your outside. Okay, this is all obviously under the ground now. And obviously it depends on the floor you're having, but you could have a mass concrete floor. Lots of insulation. All depends on the type of floor, so membrane. Insulation you could have on there. Another layer of concrete oversight. And a screed. All depends on the design for the floor. You'd have to be told that. And you could make the wall very strong by putting more wall ties coming across. Metal, look at those. Usually stainless steel strips built into walls. Some of them are even nylons, plastics. Look at that looking neater. Insulation mustn't be below the ground level, and you have mass filler here. Okay. Insulation carries on up there. block work, brickwork, and so forth. Okay, so what else? Increased number of wall ties inside the wall, continue cavity, prevent moisture. Yeah, this is another way. You may want to design to prevent any moisture in cavity. These are lots of ideas I'm going to give you now. What else? Two cells going into the wall, high speed. You may have a greater number of internal structural walls inside the building. Internal, that's an L, sorry. Okay, so the actual design of the house is more rigid in itself. So the layout, looking from the top, may be, if we just generalise, there's your building, looking down from the top. Instead of perhaps having timber internal walls, you may have a structural wall that runs from side to side. Of course, you may have a door in there, and you may have another one running from this way. So the whole structure looking down is much stronger than perhaps it would be if it had timber internal walls. And these would be structural walls, concrete block or even brick. And that would give the whole place much more rigidity. That's the word. You could have deeper foundations. I'll put that down as 4. So it can take the wind loads. Yeah, it talks about high wind speeds and lots of water. Now also I'm going to put here, and I know you can't see it for 5, it talks about rainwater. Okay, how rainfall. Well, it might be you design it so it has increased pitch to roof. So the roof pitch is higher. So here's an example. That's a relatively low pitched roof. Sorry about my drawing here. And you may have a design so the house has a much higher pitch, like that. Okay, I don't know. Let's say that the pitch is improved or increased by 30 degrees, e.g. plus 30 degrees in pitch. And the rain will just fall off it much more easily. The eave overhang here, I suppose you could reduce so the wind can't get underneath it, and try and force the roof in some way off. Okay, and I think that covers that quite well. Another way you could make sure that the ground is drier, so you could actually have better use of suds, sustainable drainage, and that could be improved. Okay, so the ground is actually kept much drier and the foundation is much more stable. Yeah, improved. Look up suds. Okay, and there's plenty of other things we could do. You could increase the density of the brickwork, so it's a stronger brick bond, and maybe have a more of a mortar which is a little bit more, you know, a little stronger in a sense. Okay. All features that you could include in the specifications that the architect may ask for. Wow, we've come to the last part of it already. Okay, let's have a look at this. Right, so evaluate. So you're discussing really pros and cons. Okay, whether a flat roof or pitch roof would be more appropriate for an office scheme. Well, an office scheme is usually something which is built for not hundreds of years. Often it's only 50s, if you like, of years, decades. Often they don't last that long, not designed to last that long. And so these buildings tend to be designed slightly, I suppose, more economically in terms of the use of materials. Right, so let's just have a think. What are the advantages of a flat roof? We're going to try this together. Advantages and disadvantages. And I suppose the only way to do it is to have down here, and you can lay it out any way you like. This could be the flat roof side. This could be pitched. I could have given myself a bit more room there, but okay. Flat roof, pitched roof. Now, just to reiterate, a flat roof is merely that, sometimes at a slight angle. There's his flat roof. There's your building. And a pitched roof, of course. Is that, okay, with a pitch. You knew that, I'm just obviously reiterating that point. So flat against pitched. Pitched roof, the water runs off. Good water run off. Flat, less expensive to build. There's less materials needed to make a flat than a pitch, and there's less skilled labour because you haven't got a tiler, and you don't have to have somebody that really has to put the flashings on. And you could argue that a lot of the work on a pitch roof can be done by one person or a team of people with similar skills, but not a pitch roof, because you've got to put the structural timbers up and form the actual shape, and then of course you've got to clad it externally with the tiles and the felt, and then lead flash it. So even for an office building, you know, even if it's metal decking they may use, sheet metal work, it's still a more specialist, more expensive fabrication method, making method. Okay, let's just go through. The flat roofs are faster, yeah, faster to construct. Less expensive. Advantage. Ooh, disadvantage. High maintenance. High maintenance over time. They may last 20 years. That's it. May do. You can get other methods of forming flat roof using glass fibre that can last 50 years, but I don't think anything can beat tiles, really, concrete or clay tiles. Let's see, what's the disadvantage? No storage. You've got no way to store anything inside. Okay, so shorter lifespan. Right, on the pitched, good storage. It's low maintenance. More material on disadvantage, more material are needed. More materials are needed, definitely. What else? More skills are needed. An advantage of pitch is attractive. This one is not very attractive. I mean, the word is aesthetic, isn't it? Architecturally aesthetic. Okay, so which one, more labour is needed for this? You've done that. More skills, more labour. Greater time required. Advantage lasts longer. Okay. Can be more expensive. Disadvantage more expensive, I would say. More materials are needed, we could put that on there. But more labour is needed as well. Attractive, yes, so low maintenance. We've got low maintenance. I think that's it. Oh, good water runoff. Yeah. Slow water runoff. Water runoff can be quite slow for that. What else? I think that's covered it quite well. Have we got slow to construct? Negative. Slow to construct. Can be so. Yeah. Slower to construct. Good. I think that's about it. Disadvantages. High maintenance, no storage. Yeah, less attractive. And I think that covers it quite well. Yeah, so there's some really good points there. There will be others, but that's a very good beginning to the answer. If you could discuss some of those points in a little bit more detail, you should get full marks for that question. Okay, and it's good to break it down. But that's a really good start, I think, for you, and that would get you a lot of the marks. Anything that is logical that would give a right answer, you'd put down as well, and you'd hopefully be awarded the marks, as long as it makes sense. Okay. I mean, another disadvantage, perhaps, of using more materials, it has a high carbon footprint. That's a disadvantage. Disadvantage. Because using more materials. However, you could argue because it lasts longer, low maintenance, you're not using more materials, perhaps more often in the repair side of things. Right, I hope that really does help you guys. We've gone through quite a lot today, and I think it covers it quite well at level 1 and level 2. And I hope that some of the extra points we put in will extend your answer if you get a slightly different question. Okay, sustainable urban drainage we talked about, so that's a bit of research there. Look up shoring to sides of trenches, and trench support is the word. Okay, trench support. Okay, and I think we've covered it quite well now. Functions of foundation we covered, and structural insulated panels we looked at. Perhaps look at those, get some images of those, so you, in your mind's eye, you know what they look like. Right, okay, thank you guys, and good luck with your exam. Soon coming up, no doubt, and goodbye from Shed Hacks.